Okay, hello everyone. Yeah, I have some background noise today, so maybe sound will not be super good, but I still wanted to try do the stream and yeah, back to our book reading, Rust book reading. Yesterday we read about struct, how defined, written, small program, and today there is a method syntax, so quite interesting topic section of the chapter 5. So let's start looking into it. Methods are similar to functions. We declare them with the fn keyword and the name. They can have parameters and a return value, and they contain some code that run when the method is called from somewhere else. Unlike functions, methods are defined within the context of a struct or an enum or trait object, which we cover in chapter 6 and chapter 17. So yeah, chapter 6 is our next chapter. And their first parameter is always self, which represents the instant of the struct the method is being called on. Okay. Yeah, I got the point, but it will be easier to discuss it on the example when we actually see the self. So defining the method, let's change the area function that has a rectangle instance as a parameter. Add instant make an area method defined on the rectangle struct as shown in listing 513. So I already have this, and now we can have implementation for the struct rectangle. We have implementation keyword here, and function area in scope of the rectangle implementation, and here is the self. Okay, let's write it down and try to run it. So here's our struct rectangle, and we can have impl keyword, use rectangle, now fn area, and as copilot suggests will be self as a param. We're going to return same as we returned previously from the area function. And we can use self fits, multiply, self height. No semicolon, since we want to return the result. Have a warning because area is never used, but we can quickly call it. And what we can do here, we can just hide this usage and use area function. So now we can discuss self a little bit, because in this example there is rect, it's our instance of the rectangle, we define it here, and when we call the area, it's actually this rect instance is the self, and we passing this rect as reference here and access the fields of the struct. So let's quickly run. this cargo run function. And yeah, it works as expected. And let's take a look what the book says about it. To define the function within the context of the rectangle, we start an implementation block for rectangle. Everything within the implementation block will be associated with the rectangle type. Then we move the area function within the implementation curly brackets and change the first, and in this case only parameter, to be self, in the signature, and everything within the body. So basically what they did, they moved this function, and what happened with the parameter, this rect reference to rectangle become self like this, because we have it since we since we invoke this method on the rect instance, we already have it, we like have information about this instance with self keyword. Okay. Where we were within the body, in main, where we called the area function and passed rect1 as an argument, we can instead use method syntax to call the area method on our rectangle instance. The method syntax goes after an instance. We add a dot followed by the method name, parentheses, and any arguments. The signature for area, we use self instead of rectangle, reference rectangle. The self is actually short for self, reference self. Sorry. Within an implementation block, the type self is an alias for the type that the implementation block is for. So this means inside of rectangle, self is alias for rectangle type. Okay. And then of course if it will be different type, it will be a reference to different type. The self is actually short for the self. Yeah, we're here. Within implementation block, the type self is an alias for the type that the implementation block is for. Method must have a parameter named self of type self for their first parameter. So Rust let you abbreviate this with only the name self in the first parameter spot. Note that we still need to use the reference in front of self shorthand to indicate that this method borrowed the self instance, just as we did in rectangle. Method can take ownership of self, borrow self immutably, as we done here, or borrow self mutably, just as they can any other parameter. So let's try to do it like this. Will it still work? Yeah, it still works, but like we cannot do, I guess, something like this anymore in this case. Yeah, you see we had the error and value borrowed, and this is it. But if we do it as the reference immutable, then it should be fine. And you see it works just fine. So that, yeah. We choose self here for the same reason we used rectangle. The function version, we don't want to take ownership, and we just want to read the data in the struct. Yeah, sorry, I lost my thought. So we choose self here, reference self here for the same reason we used rectangle is the function version. We don't want to take ownership, and we just want to read the data in the structs, not write to it. If we wanted to change the instance that we called the method on as part of what the method does, we used reference mutable self as the first parameter. Having a method that takes ownership of the instance by using just self as the first parameter is rare. Okay, yeah, this is what we tried, and this is rare case. Basically, I think before, because it doesn't make a lot of sense. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. Yeah, this is the case. We can use it. The main reason for using method instead of function is addition to providing method syntax and not having to repeat the type of self in every method signature is for organization. We've put all the things we can do with an instance of a type in one implementation block rather than making future users of your code search for capabilities of rectangle in various places in the library we provide. So yeah, there is basically the advantage. It's scoped in the rectangle, so we just can like type instance of rectangle, press dot to see autocomplete, and we like for example here I just type rect and language server protocol can sorry I did it again. It's I wrote react instead rect, but yeah, rect dot, and you see we have the m method area, so we can easily find it. We don't need to find some function, so and we don't need like pass in this function rect because we invoked, so it's just more useful, more compact, and yeah, easy to use. Note that we can choose to give a method the same name as one of the structs field. We can choose to give a method the same name as struct field. Okay. For example, we can define the method on the rectangle that also name width. Okay, let's also try to do this. Can we do it like this? or we need to create a new implementation to have self with more than 0. And we can add something like this. Correct. Width, you see we have width as a field of the struct and width as a method. We choose the method, cargo run, and here is true is our width more than 0, so it exists. Oh, and we can do this if. Yeah, I wanna try it, of course. If no, it's not so interesting as I initially thought. So basically, yeah, we can wrap it with if because it's returned the boolean, and we can use it here. Okay. Here we are choosing to make the width method return true if if the value in the instance width field is greater than 0, then false, and false if the value is 0. We can use a field within a method of the same name for any purpose. In main, when we follow rect width with parentheses, Rust knows we mean the method width. Okay, yeah, this is example. Here we have parentheses, so the method it invoke the method of the struct, and here there is no parentheses, so just a field. This is basically the difference between the field and the method. With the same name. Okay, often but not always when we give a method the same name as a field, we want it to only return the value in the field and do nothing else. Yeah, it's usually like I think it's called getters in most, not maybe most, but in many languages, at least I saw this concept a lot of different. So, for example, you can, I don't know, in Java you have protected or private method of the class. You can do access to it from outside. So you write the get some field method and you just return this private method from the inside the class. The main purpose of it, the user or from the outside don't know implementation of it, so you can change the original name, for example, of the private field, and it still don't affect the outside user of your class. So methods like this are called getters. Yeah, exactly. This is what same in Rust, maybe it's same everywhere. And Rust does not implement them automatically for struct fields as some other languages do. Getters are useful because you can make the field private, but the method public. Yeah, this actually I was talking about, but the method, so private field and the public method, and thus enable read-only access to that field as part of the type's public API. We will discuss the public and private and how to designate a field or method as public or private in chapter 7. So it's not the next, but it close. It's become more and more interesting. So private and public, something the part of the chapter 7. Where is the arrow operator? I don't know. Is it called arrow operator or? Oh yeah, I guess this is something from C++. I use, like, I tried to learn C++ in the university, but it was like over 10 years ago, so I kind of remember there's something like this, but don't really remember it. It's, I guess you have dot and you have this arrow to access different types, something related to pointers, etc. So anyways, let's just read what it says. In C and C++, two different operators are used for calling methods. You use, dot. If you call in a method on the object directly, okay, sorry. You use dot if you call in a method on the object directly, and you use arrow if you call in the method on a pointer to the object and need to dereference the pointer first. In other words, if object is a pointer, object something is similar to object. Okay, so it do additional job for it, do the referencing or not. It's similar, but is it equal? Not. Rust doesn't have equal to them. Yeah, actually, we are happy Rust doesn't have it. Instead, Rust has a feature called automatic referencing and dereferencing. Okay. Calling method is one of the few places in Rust that has this behavior. So there will be more. Okay, not just calling method. Here is how it works. When you call a method with object something, Rust automatically adds in references mutable and immutable or star, so object match the signature of the method. In other words, the following are the same. So we can, p1 can be variable and reference to p1 also can access the same method. There is no difference for us when we call it. The first one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver, the type of self. Given the receiver and name of the method, Rust can figure out definitively whenever the method is reading reference self, mutating self, or consuming self. The fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice. Okay, not sure I understand it 100%, but basically because of we always clearly know what we pass. Is it reference and the ownership model? The Rust can know is it reference, is it whatever, and can do the reference if needed. Something like this. Methods with more parameters. Let's practice using method by implementing a second method on the rectangle struct. This time we want an instance of rectangle to take another instance of rectangle and return true. If the second rectangle can fit completely within the self, the first rectangle. Otherwise, it should return false. That is, once we've defined the canHold method, we want to be able to write the program shown in listing 414. Okay, so canHold is described below, but maybe let's try to do it on our own first. So we need to implement method canHold self and another rectangle rect, and we need if self width bigger than rect width, and self height bigger than rect height. Yeah, I just freeze for a second because I think we can do something like this. No, actually we haven't read about the logical operators, I guess, yet. So okay, we didn't define the return type. This is the problem. It's one of the problem, and another, I think I did some mistake in the writing. Is it like this? No. Rectangle. Let me quickly look how we did it. Okay, yeah, it should be like this. Yeah, basically we need more practice with Rust to make me more familiar with its syntax. But yeah, I'm using different languages daily and sometimes I mess up how it should be written in particular language. So now it just says we don't use it, so we can try have another rect2. Let's do small one, small square. We need semicolon, and let's just replace it here with can hold and rect2. And since it's reference, I guess we mark it as reference. Yeah, we almost was able to do it first try. So you see the true here, and maybe we can test it if our logic really work. And now it falls, yeah, as expected. Okay, but now I actually lost where. Yeah, we finished somewhere here. And we can replace it with an example from the book with our implementation, of course. And we can save, and we also want to format cargo fmt. Let me switch buffer for a second. Yeah, it's formatted now. And let's do cargo run and see true and false. Yeah, you see we have here same true and false. The expected output would look like the following, because both dimension of rect2 are smaller than the dimension of rect1, but rect3 is wider than rect1. Okay, we know we want to define a method, so it will be within the implementation rectangle block. The method name will be canHold, and it will take a mutable borrow of another rectangle as parameter. We can tell what the type of the parameter will be by looking at the code that calls the method. Rect1 canHold reference rect2 passes in rect2, which is immutable borrow to the rect2, an instance of rectangle. This makes sense because we only need to read rect2 rather than write, which would mean we need a mutable borrow, and we want main to retain ownership of rect2 so we can use it again after the calling canHold method. The return value of canHold will be a boolean, and the implementation will check whether the width and height of self greater than the width and height of the other rectangle respectively. Let's add the new canHold method to the implementation block from listing 513 shown in listing 515. So yeah, this is basically explanation. Sorry, let me have a sip of water. Yeah, I don't really speak daily a lot like this on stream, so I need to train myself, do it properly. My voice, especially in the end of the day, maybe not trained enough. But yeah, basically we continue to repeat this our ownership concepts. So we pass immutable reference which don't do move of our ownership. We just want to be able to return the value, and then we can be able to use this variable again. So like rect2 we pass is the mutable reference, so we can use it again. But if we pass it is mutable, I don't remember, is it cannot borrow as mutable as it is not declared as mutable. So yeah, it should be also be declared something like this here, I guess. Yeah, now you see if it's mutable reference, we can't use immutable reference after. And immutable or mutable, whatever. But since we use immutable reference, we can use as many as we need without moving ownership. And we even can print, I don't know, rect2 is everything is working. So when we run this code with main function, we'll get our desired output. Methods can take multiple parameters that we add to the signature after the self parameter, and those parameters work just like parameters in functions. Exactly. So this is a couple last topics in our chapter. Associated functions. All functions defined within the implementation blocks are called associated functions because they associated within the type name after the implementation. So if we have implementation for rectangle, it's associated function with rectangle. Yep. We can define associated functions that don't have self as their first parameter, and thus are not methods, because they don't need an instance of the type to work with. We've already used one function like this, the string from function that define it on the string type. So yeah, it's actually something different here. it's not. So I actually curious if we, is it like this? Yeah, let's just read to the end. Associated functions that aren't methods are often used to constructors that will return new instance of the struct. They are often called new, but new isn't a special name and isn't built into the language. For example, we could choose to provide an associated function named square that would have one dimension parameter and use that as both width and height, thus making it easier to create a square rather than having to specify the same value twice. So yeah, new is resort keyword in many languages. I'm sure it's used in the Objective-C, maybe in C++ too, but can't really tell exactly. But let's try do the square implementation. I think, can we do another implementation like this? Just have many implementations, not just like to have different functions in different implementation blocks. This one we want to test. So have function that of square size is 32 and it returns self, and here we create a rectangle like this. No error complaints, so let's have now rect1 will be, so if it's same as from we use for string, it should code with 2 semicolon, I guess. And this is works. Yeah, exactly. Yeah, we get it correctly. So self keyword, yeah, we did return self. In the return type and in the body of the function are aliases for the type that appears after the implementation keyword, which in this case is rectangle. Okay. To call this associated function, we use the 2 semicolon, sorry, not 2 colon syntax with the struct name. Is an example. Yeah, exactly like we did here. This function is namespace, but the struct, the 2 colon syntax is used for both associated function and namespaces created by the modulus. We'll discuss modulus in chapter 7. Chapter 7 waiting for us. Okay, let's take a look again. So associated function is the function that doesn't have self as a parameter. So we put size, but we didn't put self or reference to the self instance. This means we don't need exact instance like rect 1 to invoke it, for example, for width. method, because we don't pass the instance of direct. And in this case, we just need rectangle, namespace, and because as you see, our function live in this namespace in the implementation block rectangle, and then we can access associated function like this. Okay. Multiple implementation blocks, and we already tried it. Look, we have one and we have two. I was expected it will be like this. Yeah, it's nice to catch things for a hit. So each struct is allowed to have multiple implementation blocks. For example, list in 5.15 is equivalent to the code shown in list in 5.16, which has each method in its own implementation block area and can hold. Let's just, yeah, we have different blocks, implementation blocks, but this one contains associated function, and we actually haven't tried to have different implementation blocks for methods. So our curiosity forced us to try this case as well. And you see no errors, and we create some errors in my NeoVim. Let's just restart it. Yeah, basically works as expected. We can have many implementation, whatever it's methods or associated functions. I guess it works pretty nice when like we have it in different files as well, just for sake of our program structure. We don't write any programs yet, but this our goal. We will learn the Rust and we start do programs with it. This is our what forced us do it actually. So there is no reason to separate this method into multiple implementation blocks here, but this is a valid syntax. We'll see a case in which multiple implementation blocks are useful in chapter 10, where we discuss generic types and traits. Yeah, for sure. We like if we have like list of methods and it goes one by one, and sure doesn't make any sense to put it in different implementation block, I guess in most cases, but yeah, there should be some cases that makes a lot of sense. As I said, for example, we need implementation in different places. Maybe we even can use some struct that implemented by, I don't know, library, and then we would like to have our own implementation for struct of this library. We want to extend its functionality, have super own piece on it, and this is, yeah, it's actually could be really powerful. We can just take any struct and extend it with our own additional method. with our own implementation block. This is actually huge. I already like it. I haven't used it yet, but I already really like it. So the summary is: structs let you create custom types that are meaningful for your domain. By using struct, you can keep associated pieces of data connected to each other and name each piece to make your code clear. In implementation blocks, you can define functions that are associated with your type, and methods are kind of associated function that let you specify the behavior that instance of your struct have. But structs aren't the only way you can create custom types. Let's turn to Rust enums feature to add another tool to your toolbox. So yeah, this is it. This is chapter 5, structs. Was quite cool, and next will be enums and pattern matching. I guess we saw it in this chapter 2, just guessing game, simple program, and we use match there. Was oh, it's actually quite cool feature guess, but yeah, we need to try how it's work in real life when we will do program more here on this channel. But for today, I think this is it. Yeah, my voice, I kind of tired. It's 10 p.m. my local time. A bit tired, so as soon as I have time, probably tomorrow, I'll start with enums. So thank you guys for watching, and see you tomorrow.